Here's our starter. So it's a back-to-back stem and leaf. So if you'd like to pause the video and have a go at the question, please. Right. I'm now going to go over it. So first of all, I'm going to in purple. So I'm expecting you, so I've paused it and I've done it. Right, there's 15 boys. So if there's 15 boys, your median will be, if I could spell median, that would be good. Median is half of the 15.1. So it's going to be the 8th. 1, 2, 3, 4, 5, 6, 7, 8. It's 8. Oh, interesting. 8 hours. Your lower quartile is going to be a quarter of 15 plus 1. It will be the 4th. 1, 2, 3, 4. It's 6 hours. And your upper quartile is going to be 3/4 of 15 plus 1, which is 12 hours. It's not 12 hours, it's the 12th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 24 hours. It hasn't asked for the interquartile range, so don't get any marks for it. State one advantage and one disadvantage over using stem and leaf diagrams rather than box and whisker. Well, stem and leaf diagram is all about raw data. So instantly, for your stem and leaf, you can actually see the values, right? You have the exact values, you can see them. Whereas obviously on a box and whisker, you haven't got that. And on a box and whisker, instantly, you know what the median and your interquartile range. Okay, your box and whisker has, an instant summary of your data. So that would be, an advantage. So they've both got great things. We're going to look at today a bit of a recap from GCSE to start with, the mean. Now, if you remember, finding the mean at GCSE, we would have talked about that as being the more mathematical average. So raw data here, you would add them up and divide by how many there are. So have we got 21 over 4? So we would have 5.25. Here we can still see these exact values. We've got 5 zeros, we've got 7 ones, we've got 10 twos and so on. And the way that we would find our median here is we would multiply, wouldn't we? We would say 5 lots of zeros, 7 lots of 1, 10 lots of 2, 4 lots of 3, and 1 lot of 4, and we would add them together. So we've got 27, 39, 43, I think, is that right? 27, add 16. And then we would add up how many values we had, 12, 22, 26, 27. So our mean, and it would be an exact value. These are just exact values that have been put into a table. They haven't been grouped. 43 divided by 27, whatever that would be. And here we have what we would have called a grouped frequency table. And of course, if you remember rightly, to find the mean, and it's an estimate because of our grouped frequencies. And here you can see we've got standard GCSE ones. We haven't got to worry about anything here. We would go with our midpoint. Between 0 and 5, we'd have 2.5, 7.5 and 12.5. And the minute we've done that, that's not really any use to us anymore. So we say we've got 4 lots of 2.5, which is 10. We've got 7 lots of 7.5. So that's going to be what, 49 at 3.5. So 52.5. And 3 lots of 12.5. So that's 36, 37.5. Sorry, that looks a bit dodgy there. So if I add these together, I've got 9, 10. And I've got 6, 9, I want to say 100. And here altogether I've got 14 things. So an estimate, because of the group data, of the mean is 100 over 14. And you just want to make sure your answer is somewhere between 0 and 5. So 100 over 14. I'll switch my calculator on, sorry. So 100 over 14. Stuck in a periodic table there. 100 divided by 14, you can see is 7.1. And that does indeed lie between 0 and 15. Right. What we're going to look at, and so our title of what we're going to do today is we're going to meet a new measure of spread. So far, the measures of spread we've been dealing with are the range, which is rather crude measure of spread, and the interquartile range. And the interquartile range aligns itself very much with the median. We're going to meet a more mathematical measure of spread, standard deviation, and really we find out more about what the standard deviation is really in year 13 statistics. We don't really delve very much into what it is particularly. We have a really strong definition of what it is when we meet the normal distribution in year 13, but we're just going to go with it here. Calculating the mean is pretty much the same as on AS year 12 as it was at GCSE, only we're really going to do it on a calculator. If each data value is called X, we refer to the mean as X bar. Okay, X bar represents the mean. And with raw data, we think of finding the mean as adding up each value of X. So what we use is this Greek letter here. Now this is the Greek letter sigma. So I'll just draw that a bit better. Some of you may have met it before. It's capital sigma. We like sigma a lot in statistics. This is capital sigma, and this means the sum of. So we would think of X bar as the sum of all the X values divided by how many there are, where N is your number of values. So it's just a way of writing it. With a frequency table, we like to, it's you know, you find the mean exactly the same way, but we like formula. So with a frequency table, the mean we think of, it's the sum of the frequencies times X over the number of values, or the sum of the frequencies times X over the sum of the frequencies. So if we go back here, we could call that F and these X. So this column is F times X. That's the sum of the frequencies times X, and this is the sum of the frequencies. And that's how we worked out the mean, using that formula. And it's the same idea with group data. It's just that you've introduced the midpoint. So nothing new. Right, again, we wouldn't write this down. This is me sort of slightly trying to show you where it comes from. So don't worry if you don't really get it. It's just me sort of showing you. So what is the standard deviation? What a standard deviation is, looks at how far each value deviates from the mean. So first of all, you need to get the mean. And then by subtracting, right, you then work out how far every single value is away from that mean. And so you subtract the mean off each value. And these are called the mean deviations. And what we want to do is find the mean of those. Now, because some of the mean deviations are positive and some of them are negative, we run into a bit of a problem because whenever we add them up, they cancel each other out. So we often end up with 0. So we're always going to end up with 0, which is rubbish because this is going to be a measure of spread. So to counteract that, we square them, we find the mean of the squares of those deviations, and then to counteract the squaring, we square root it. Okay, don't worry about it. You're going to be given a formula, and we hardly ever use this method anyway. It's just to show you where it comes from. Now, before we square root it, it's going to be called something called the variance. And the minute we square root it, it becomes the standard deviation. So don't worry if you're confused. I'm just trying to show you where it comes from. Right, again, don't write this down. This is an awful thing to work with. That's why we don't really work with it ever. But I'm just showing you how it originates. So here we have 9 values. And the first thing I've done is I found the mean. So they've been added up and divided by 9. So the mean, or x bar, you can see is 5.9. So I'm now going to use this very sort of slow and elaborate way to find the standard deviation. I'm going to find the variance, then I'm going to square root it, I'm going to find the standard deviation. So the first thing I'm going to do is I'm going to subtract the mean of all these x values. So I'm going to do 6.5, take away 5.9, 5.9, take away 5.9. So I've got all these values here. So these are my mean, well, these are my deviations from the mean, these values. Now, if I add them up, I'm going to get 0. So if I try and find the mean average of them, it's going to be 0 every time. And that's just going to be a waste of time. So what I'm now going to do is I'm going to square them. So I've squared these, and by squaring them, I've got rid of the negativity. So what I would now like to do is find the mean of these values. And when I find the mean of something, I have to add them up and divide by how many there are. So you can see if we add those up, we're going to get 0.76. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to divide by 9. So we've got 0.76 and we're going to divide that by 9. So what I've really done here is this. It's the sum of x minus x bar all squared all over n. I've made that a little bit high there, bring that back down. And I want rid, I sort of will need to counteract that squaring. So what I'm going to do is I'm going to square root both sides. So I square root this. and I get 0.291. So my standard deviation, which is a measure of spread, which we will talk about what it really is later in the course, measure of spread is 0.291. Now this formula is awful, okay? It's an awful, awful formula. You will be given this in your formula sheet in the exam, and occasionally they might get you to use it, but it would be very specific how they get you to use it. Using knowledge of sigma, so people that do further maths at the beginning of your year 13 course, your A2 further maths course, you'll do work with sigma and you'll be able to rearrange this formula as this formula. This tends to be the formula that we use, okay, to find the variance and then subsequently square root it and get the standard deviation. So this is the formula that we would use, and again, this will be given to you in your formula sheet. So what it means is you square all the x values and then you divide by the number of x values, take away the mean squared. So we used to think of it before you had to learn it. Well, before when we used to have to learn it, you don't have to learn it anymore because you're going to be given it. We used to think of it as the mean of the squares take away the square of the mean. Again, I don't think you need to have written any of this down yet, other than maybe this is your formula. So far, this is what we've got. We've got the mean, x bar is the sum of x over n. This is for raw data. And your standard deviation, and you're going to be told this formula is the sum of x squared over n minus the mean squared, all square rooted. If we bring in frequencies, all you get is like an added f. And your standard deviation. Okay, becomes that. But again, you're going to be told this in an exam. So again, feel free to pause it. Right, okay, I've just repeated it here. It's just for some reason, it's now put red boxes around when I've used sigma. It's a bit unfortunate. Okay. However, we tend to use our calculator, all right? You know, if you were doing this without a calculator, you would find the mean, you would add them all together, and divide by 6. So it's 213 divided by 6, and you would work that out. The standard deviation, on the other hand, you would square them and then add them together. So it would be 34 squared plus 45 squared plus 23 squared plus 16 squared. So can you see already 56 squared? So we would work out the sum of their squares, which is 8,623 divided by how many there are, take away your mean squared. Now this, they're not really interested in you like number crunching like this. We don't really want to be doing it. It tends to be all done on your graphical calculator. So get your calculator. I'll show you what you're going to do. The first thing you're going to do is you're going to choose the stat menu. So statistics, it's option 2, but it's the second thing there. So you should, and you're going to end up with having something that looks like this. So you might want to zoom in. I can't make it any, I don't think I can. If you see, I'm worried if I now move it, then I'm not going to be able to get it back. So the first thing I'm going to do is I'm going to delete everything in this column. So I click on the arrow and I'm going to delete all. And then I'm going to scroll into this column and again, I'm going to delete all. So hopefully your columns are free. So what I'm going to do, and what I've really messed up here, is that I actually can't see my question. So I don't know if this is going to let me clip my question. I've really messed this up here. So I'm just going to quickly write those down. So I've got 34, 45, 23, 16 and 56. 34, 45, 23, 16, 39 and 56. So what I can do is I can enter them into my calculator. So I need a way of getting that question in there. That's what I want that to be, isn't it? It's not gonna let me do it. So in this, right, first thing we're gonna do is we're gonna do setup. So I need this on display so I can see calc. So here is calc, okay? So what I'm going to do is I click on calc and I've then got set. Now this is what your setup has to be. The thing at the top should say 1 var and it should say list 1. Okay, if it doesn't say list 1, click on list and just literally type 1 in. Okay, your next category should say 1 var and it should then say freq, F-R-E-Q, and then it should say list 2. If it doesn't say list 2, click on list and enter 2. Now you don't need to worry about any of the other stuff. Okay, so press execute and we are using 1 variable. So you're going to enter 1 var, oh sorry, I haven't done it yet, press X. So what you're going to do is in the left hand column, you're going to enter those values. So I think the values were 34, 45, 23, 16, 39 and 56. You're now, so they're your X values. You're now going to scroll into the next column. Now, because this isn't in a frequency table, there's only one of each. This next column is your frequency column. So each frequency will be 1. Okay. You're then going to click on 1 var for 1 variable. in your maths A level, we don't use two-var or reg, okay? These are things that we used to use, we don't use, but they're also amazing. So this is all about correlation, but we don't use it in A-level maths anymore. One var is F1, and you will see that your calculator has done a shed load of calculations for you. It's just amazing. It's the best, right? It's life-changing. So instantly I can see the mean is 35.5. I can see that the sum of the x values are 213. The sum of the x squared values are 8623. And now I'm just going to go back to the smartboardy bit. You've got two values here. So you've got something that looks like this. Now this is going to be your standard deviation. So we'll make a note of this in a minute. So this is your standard deviation. Okay, so if I go back, I can read off my standard deviation is 13.3. Sorry, there isn't an X there. Sometimes there used to be an X. So my standard deviation is 13.3. And if we go back to the calculator, there's also an SX here. Right, we never use that on the A level. We've also got the number of values. That's a really good check. And if you click on the down arrow, she said, maybe on the cursor, it's also got your quartiles. So 23, it's got the median, it's got, so Q1, quartile 1, lower quartile, median, quartile 3, upper quartile. So it's got loads of stuff there for you. It's amazing, absolutely amazing. So I now want to go back up there. So if I was going to work out the mean, I would put it into my calculator. So I would write down mean, and I would make it look like I was calculating it, but I'm literally reading these values off my calculator display, 213 and 6, and I'm not even going to work it out on my calculator. It's 35.5. I just literally write it down. And for my standard deviation, I get the formula on the formula booklet in front of me and make it look like I'm putting it in. So my standard deviation, I'm reading these values off. 8623 over 6 minus 35.5 all squared. Don't put it in my calculator. I then read off my calculator display. So I'll do a little summary in a moment. Here we have a grouped frequency table. Now, if you look at the groups, they've been rounded, but this isn't an issue when you're finding the mean and the standard deviation. I am going to need my midpoint, but the midpoint of 1 and 5 is exactly the same as the midpoint between 0.5 and 5.5. It's exactly the same midpoint. So my midpoint is 3. My midpoint of 5.5 to 10.5 is exactly the same midpoint as between 6 and 10. You've just got a half in both directions. So that's going to be 8. And here, so not as nice a midpoint here, that's going to be 15.5. And, okay, this is your X value. So just be careful. So if you go to if we get our calculators now, and I really, really wish I could show my calculator. I only seem to be able to do it on the side. anyone's worked that way, they can show it. No, I don't know how to do that. So I've literally got, I've got 4, 7 and 3. So I'm now going to get my calculator. So if I now exit that, and the issues are I'm going to have to delete everything. So I'm not wanting to do that. That is not what I wanted to do. Press exit, okay? Get the arrow, delete all, okay? And scroll across, delete all. It just takes a little while to get used to it. So our midpoints, which my x values, which I've now totally forgotten, are 3, 8 and 15.5. So they are my values of x. So 3, 8, 15.5. And now my frequencies scroll across. So it's always x values. You've set your calculator up for this. You can change it, but I just don't want to change mine. Once I've got it set, I'm set there. List 2 are my frequencies. And if you go back, my frequencies were 4, 7 and 3. So 4, 7 and 3. Okay, fantastic. Now where's my calc? It's not there, so I press the arrow. It's not there, so I just keep pressing that arrow. There's calc, and it's one variable that I want, okay? One variable, one unknown, x. Click on it, and it's just there. It's all there, like a dream. So the issue with the calculator, and I'll just write a little bit at the end about it. Issue with the calculator is it's such a shame it doesn't put an F in there, okay? Because really this isn't the sum of the x values, it's the sum of fx, and this is the sum of fx squared. So I'm just going to write these down. So I think the sum of fx squared is 114.5. The sum of fx, that's sum of fx. Sum of fx squared is 1204.75. My mean is 8.18, and my standard deviation, I can't see, is 4.38. Okay, so I would now say my mean is, and again, I'm literally reading the values from the calculator. I'm feeling so late, n is 14, but if I was unsure, it's a really good check on that calculator screen. So, and again, literally reading it off my calculator, I am not calculating it. And my standard deviation, which I could use SD, or if I wanted to, I could use my lowercase sigma. It's going to be the square root, and I've got this formula, which I know is the sum of fx squared, 1204.75, all over my value of n, which is 14, minus 8.18 squared. But I don't really need to even do that. I'm just doing that because, I feel it sort of backs it up. It's some method. It would be absolutely fine for me to literally just write that down off my calculator, 4.38. So that's my standard deviation. Right. So, things that we need to know. So we need to know that is your standard deviation. Okay, on your calculator, we never use the S on the calculator display. And we need to remember, if it asks us for the variance, it's the standard deviation squared. The variance doesn't really mean anything. It's just a convenient, you know, doesn't need the square root. So it's just the standard deviation squared. It doesn't really mean anything. So I don't know why that's me working through the question. Here we have a question about Eleanor. So have a go at this question. So pause the video, have a go at putting it in your calculator. So you would put, this is like my first example, you would enter it in your calculator and then you would put all your frequencies as 0. So pause the video and you can see that the mean, here are the answers. The mean is 70 and it's a show that question. So here you would need to see it going into the formula. And have a go at this. It's a table. In fact, you've seen this table before with histograms, but with histograms, you're going to have to think about the categories. Because there's a frequency of 0, it doesn't matter that that's an open-ended category. We'll talk about open-ended categories next lesson. And it doesn't matter that that is because it's a 0, frequency of 0. So you will need to find the midpoints. So your x values will be the midpoints of these. So 29 and so on, 33. These are your frequencies. And you will put it into your calculator and you will get the mean and the standard deviation, literally reading them off. Just be careful, it asks you for standard deviation and not variance. So pause the video again and then check your answers with these. So there's the mean and there's the standard deviation. Well done. Phew.